Good afternoon, students. So now we are starting with a new chapter, another very important chapter: work, power, energy, and collisions. Number of lectures required will be approximately 8 or 9. Okay. As far as the first part of it is concerned, you already know this from scalars and vectors. From your school level knowledge, you used to say work done is force into displacement. Your college level knowledge says that no, work done is not force into displacement. It is dot product of force vector and displacement vector. That means it is Fx cos theta, and therefore that theta plays very important role, because if theta is acute, then can you say cos of theta will be positive number? Example, cos of 30 is root 3 by 2, cos of 60 is half, and so on. So if theta is acute, cos of theta is positive value, and therefore work done will be positive. If theta is obtuse, for example, cos of 120 degree is minus half, cos of 135 degree is minus 1 by 2, and so on, then can I say cos of theta will be negative value, and therefore work done can be negative also. And if theta is 90, example, circular motion, right? Example, circular motion. If this is the center of the circle, and if this is the particle performing circular motion, can we say whether it is UCM or CM? Whether it is UCM or CM, centripetal force is compulsory, because without that circular motion cannot happen. So this is the direction of centripetal force. For sure, this is the direction of displacement vector. Yes or no? Angle between them for sure is 90 degrees, always wherever the particle goes. And therefore, can we say work done will be 0? So work done may be positive, work done may be negative, and work done may be 0 also. This is work done. The basic definition. Thereafter we studied the units, dimensions, etc. What is the unit? It is force into displacement, so it is kilogram into meter square per second square, and therefore it will be m1 L2 T minus 2. Thereafter you have got different conversions. For example, 1 joule is 10⁷ earth. Then depending on the chapter, sometimes we use convenient units. Joule is always the official unit, right? But sometimes we use kilocalorie. Example, chapter heat, 1 kilocalorie is approximately 4,200 joules. Come to zyada, multiply by. Then I'm sure in electrostatics you have heard 1 electron volt is 1.6 into 10⁻⁻19 joules. Yes or no? So this is the basic information which you already have. Now if I write work done as force dot displacement, then can I write this as Fs cos theta? Right? Remember, projection of one vector on the other. Means if I want, I can resolve F into F cos theta and F sin theta, and I can keep S as it is. If I want, I can resolve S into S cos theta and S sin theta, and I can keep F as it is. So when I write Fs cos theta, you know that dot product is commutative. So either it is F cos theta into S, that is also fine, or it is S cos theta into F, that is also fine. Ultimately, you will end up to the same answer. Thereafter, we talk about work done by variable force. Work done by a variable force. Suppose I am having force vector as Fxi plus Fyj plus Fzk, and displacement vector which also could be written as R vector. Yaad karo. Because R can be written as x times I plus y times j plus z times k. So if I write this as x times I plus y times j plus z times k, then remember work done, which is force dot displacement, can also be written as Fxi plus Fyj plus Fzk dot xi plus yj plus zk. Obviously there will be 9 terms. This into this bracket, this into this bracket, this into this bracket. Out of these 9 terms, 3 terms will survive, because you know that I bar dot I bar, j bar dot j bar, and k bar dot k bar are 1. The rest all are 0. So our answer of work done was this also. Is it Fxx plus Fyy plus Fzz? Yes or no? So this is another style of writing work done. Next, if I write work done as force into displacement, is correct. can I say more correct, is small amount of work is force into small amount of displacement. Yes or no? Therefore, if I want to calculate total amount of work, is it integration of dW? Is it integration of F into dx? Right? Where you are going from x1 to x2. Right? So if you write dW, it is small amount of work in going from W1 to W2. Right? So x1 to x2. This is more sensible. This is more sensible. Right? This is work done by variable force, and then we will talk about work done by several forces. But before that, what will be the graphical meaning of this? Very, very beautiful meaning. Very, very beautiful meaning. Suppose I give you on y-axis force and on x-axis displacement. On y-axis I am giving you force, this is in Newton. The unit is Newton. And on x-axis I am giving you displacement, which is in meter. And suppose you are going from point A to point B. This is the path taken. Right? Then what you should do is, from point A, that means your first point, it is called initial limit, lower limit. Draw perpendicular here. Let us call this as x1 because this is displacement axis. And this is another perpendicular, this is x2. Okay. What I am shading is called area under the curve. This is called area under the curve. This is called area under the curve. And area under the curve means work done. सोचो बेटा इसके बारे में. सोचो इसके बारे में. What is the meaning of area? Product of two lengths. मेरे पास एक x coordinate वाला length है और मेरे पास एक y coordinate वाला length है. So can I say the shaded portion is area under the curve? अब ये जो मैंने ढूंढा, that is W. F dot S या तो F dot X. But if I want to be more systematic, then I should select two points which are extremely close to each other, say P and Q. Correct? From P, I will draw perpendicular on x-axis. From Q, I will draw perpendicular on x-axis. And now this green shaded portion is going to give me what? Is it dW? Is equal to F into dx, where dx is infinitesimally small element. So if you want, barabar na? So if you want to find out graphically the meaning of work done, then it is the area under the curve of the graph of force versus displacement. Then it is area under the curve of graph force versus displacement. Now suppose I have got multiple displacements and I have got multiple forces. That means these multiple displacements are because of the multiple forces. Then the total amount of work done will be sum of all these work done. Means what? I will say dW1 plus dW2 plus blah 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 dWn will be equal to W. And this means this is the work done. This is the work done by several forces. So when you talk about work done by several forces, the individual work dones are independent of others. What do I mean by this? He is asking me a question, I understand, I analyze, I give him the answer. He stops, he is asking me a question, same thing. He stops, she is asking me a question, same thing. Right? But what if all of them ask me the question simultaneously? Right? She does not know what they are going to ask. He does not know what they are going to ask. He does not know what they are going to ask. That means, are they independent of each other? Down the line, the total message which I receive is combination of all this. Yes or no? So that is called work done by several forces. For a particular path, do you agree with me? Work done is independent of time. Very, very, very important. Work done is independent of time. It is the power which depends on time. Power is rate of doing work. Example, I am giving you a DCT paper which is comprising of 10 questions. It is the same question for all of you. Same number of questions. Same time given to all of you. Time given to you is 15 minutes. Right? Now some students फिनिश इन 8 minutes. 7 minutes बचा. इसका मतलब ये नहीं कि वो स्टूडेंट 11 to 20 नंबर का भी क्वेश्चन सॉल्व करेगा. होगा तो करेगा ना. क्वेश्चन पेपर में ही 10 क्वेश्चंस थे. You were intelligent enough, you studied well, you could crack the questions in 7 minutes. So your rate of doing work is more, right? But work done by you is not more, just because I gave you more time. So can we say work done is independent of time? It depends on displacement. Is that clear? Other student takes 15 questions, 15 minutes. Moderate, power wise, not work wise. Work दोनों ने सेम किया. पहले वाले ने भी 10 क्वेश्चन सॉल्व किया, दूसरे वाले ने भी 10 क्वेश्चन. तीसरे वाले ने 15 मिनट में 12 क्वेश्चन सॉल्व किया. राइट? अभी भी उसका 3 क्वेश्चन बाकी है. बिफोर आई टेक द पेपर अवे, कुछ भी करके बबल मार्क करते यार, 15 क्वेश्चंस खत्म करते. आर वी गेटिंग दिस? इसका मतलब उसका 3 क्वेश्चन एक्चुअली हुआ ही नहीं था. ब्लफ मार्क. राइट? क्योंकि हो सकता है पेपर शुरू होने से पहले मैंने बोला होगा कि दिस टाइम द चेकिंग विल बी डन इन सच अ वे दैट देयर इज नो नेगेटिव मार्किंग. तो यू विल से कि 0 मिलेगा ना, उससे ज्यादा तो क्या मिलेगा. फेंकते हैं, शायद 3 में से 2 राइट हो जाए. Because negative marking is not there. Logic समझा बेटा? So work done is independent of time. यहाँ तक समझा? अब इसका जो graphical representation है, उसके ऊपर से question ऐसा आता है, कि suppose I'm giving you a graph of force versus displacement. Right? On y-axis I'm giving you force in Newton. And on x-axis I am giving you displacement in meter. And suppose these labelings are 0, 1, 2, 3, 4, 5, 6, 7, 8 meters. Right? On y-axis I am taking this as 5, 10, 15 Newton. Minus 5, minus 10, minus 15 Newton. And I am giving you graph like this. Suppose this is my graph paper. Okay, this is my graph paper. That means the calibration is done on x-axis as per 1 and calibration on y-axis is done as 5. Okay, and now if I give you the graph like this, and if I ask you what is the work done, check this please. I am giving you the graph like this. I am giving you the graph like this, right? Over here you see triangle, over here you see rectangle, over here you see trapezium, over here you see rectangle again, over here you see triangle. This is unbounded figure because ये मैंने complete नहीं किया है, ये infinity तक जा रहा है. Then can I say area under the curve will be area of triangle number 1, area of square या तो rectangle, area of trapezium, then area of rectangle again, and then area of triangle again. So area under the curve, will it be area number 1 plus area number 2 plus area number 3 plus area number 4 plus area number 5, which is area of triangle plus area of rectangle plus area of trapezium plus area of rectangle again plus area of triangle? Yes or no? What is the first area? Is it half into base? Base is 0 to 1, that is 1, into height is 5. समझ में आ रहा है? This value is 1, no? Displacement is 1, and this value is 5, which is the height of the triangle, which is force, and force is 5 Newton. What is the area of this rectangle? Is it 1 into 10? So is it 1 into minus 10? Work done can be negative, don't forget. Work done can be negative. If you see this part, 1, 3 and 5, are they in the first quadrant? Yes. Both the coordinates are positive. X is positive, Y is positive, product is positive. But if you see second and fourth, are they in the fourth quadrant? First, second, third, fourth. First, second, third, fourth. So fourth में, can I say this area will be negative? So sign conventions say that If both force and displacement are positive, work done is positive. Of course, हम लोग इसमें cos theta गिन ही नहीं रहे, because ये cos theta का question ही नहीं है. This is graphical question. If one of the coordinates is negative, then can we say work done is negative? So ये मैंने minus 10 क्यों लिखा समझा? We are on area of trapezium now. What is area of trapezium? Half into sum of parallel sides into height. Right? So what are the sum of parallel sides? ये बेटा ये 3 है और ये 6 है. मतलब ये ऊपर का साइड 3 हुआ, ऊपर का साइड 3 हुआ और नीचे का साइड 4 हुआ. बराबर? तो हाफ इंटू सम ऑफ पैरेलल साइड इज हाफ इंटू 3 इंटू 4. हाइट कितना है? 5 न्यूटन. हाइट इज 5 न्यूटन. Yes or no? Then after we talk about this area of rectangle. So is it 1 into minus 5, 1 into minus 5, and finally this is area of triangle again. So is it half into 1 into 5, half into 1 into 5. So when you talk about this is 2.5, this is 2.5, this is also 2.5, which is 5, right? This 5 and this minus 5, right? This 5 and this minus 5 go. बराबर? ये बेटा 2.5 हो गया, ये 2.5 हो गया, टोटल 5 हो गया, ये minus 5 है, they go. This is minus 10, and that is 7 5 are 35. 35 upon 2, 17.5. That means my final answer is plus 7.5 joule. My answer is plus 7.5 joule. अच्छे से समझा? Super duper sure. Finally we say that work done can be expressed as change in kinetic energy or else sometimes change in potential energy also. Change in kinetic energy means it is half m final velocity square minus initial velocity square. Usually when they talk about potential energy, it is half k x2 square minus x1 square. याद करो बेटा, what was the potential energy stored in a spring? Half k x square. So if I stretch the spring by 2 centimeter, and if the work done is 5 joule, if I stretch it by 4 centimeter, can I say work done will be 20 joule? Because displacement मैंने double किया, so work done double का square होगा. Yes or no? So it is double का square, that is 4 into 5. Answer will be 20. So what is the difference of work done? ये work 1 था, ये work 2 था. Is the difference 15 joule? Right? How this comes? We are going to prove this. How this comes? We are going to prove this today itself. I'm just going type wise, but I'm going type wise. First I'm talking about work. Next I will talk about power. Next, if time permits, I will talk about kinetic energy and potential energy independently. If time does not permit, no problem, we'll do this small proof today. Right? Whenever I am giving you time to study, please make sure that every line, every word you are reading very carefully. Because this first lecture and the second lecture, what you are going to study, very beautiful theoretical MCQs come on that. Very beautiful theoretical MCQs. So when I give you time, revise everything very well. And don't forget, simultaneously, from lecture number 1 itself, your iPad notes have started. Your synopsis has started. Means whatever I am teaching you right now is going to be part of your iPad notes. Okay. Maybe in the third lecture. Today is first lecture. Next week I will get 2 lectures. So maybe in the third lecture I will give you the iPad notes. Right? Before you go on vacation, mostly you should get the iPad notes. Right? Your time starts now. You are on page number 1. You are on page number 1. I have taught up to page number 2 everything except the note. नोट में एक दो सेंटेंसेस में मार्क करवाता हूँ, आप उसको हाईलाइट करोगे. इन दिस चैप्टर प्लीज बी विद द हाइलाइटर ऑलवेज. आर यू ऑन पेज नंबर 2? बॉटम ऑफ द पेज, नोट. There are 4 points. The first point is effect of work is change in kinetic energy. Effect of work is change in kinetic energy. लिखो उधर. For the proof, refer page number 6. For the proof, refer page number 6. I am teaching page number 6 का proof today itself. Right? We are going to do this proof today itself. This is note number 1. Are you on note number 2? ये सारी चीजें बेटा मैं अपनी स्पीच में बोल चुका हूँ. Right? When several forces are acting on the body, the work done by the force for a particular displacement is independent of others. Everybody here. He is asking me a question, independent of this two. He is asking me a question, independent of this two. So if this is the body, yeah, influenced by force number 1, displaced by that force. Influenced by force number 2, displaced to some other value. So the net force acting on this is going to be sum of all. Yes sir? But when I think about an individual force, the displacement will be decided by that force only, not the others. For example, if I take different types, this body is influenced by electrostatic force, magnetic force, gravitational force, spring force. Are they different forces? Right? So the displacement because of one particular force will be dependent on that force, not on the others. Note number 3. Note number 3. Work done by the source or agent is the applied force. This is in accordance with Newton's first law. Unless and until the body is acted upon by some external unbalanced force, if the body is at rest, it remains at rest, and if it is moving, it continues to do so in the same direction with same velocity. If suppose this pen is here, and if I don't touch this pen for years together, there is no other external force. Can I say this pen will remain here only? So if the source is there, if the agent is there to move the body, then only work is done, not otherwise. However great amount of force I apply, but if the displacement is 0, can you say work done is 0? Yes. I am applying tremendous amount of force on this wall. Right? Ultimately my muscles are made, but the wall is not moved. So what is the work done to move the wall? Yes. Are you getting this? If I am lifting this pen up, that means displacement is in the direction of applied force. So work done by my muscle power is positive. Work done by my muscle power is positive. But if I think about work done in reference with gravitational force, can we say it is negative? Because gravitational force is trying to pull this body down. Gravitational force is acting down. But am I successful in moving the body up? So work done in reference with gravitational force is negative. But work done in reference with my muscle power is positive. If I release this body, then can I say work done by gravitational force is positive? Because displacement is down, work done also, gravitational force also is down. Yes or no? Sentence number 4. Note last sentence of page 2. For a particular displacement, work done is independent of time. Yes, here you are. Highlight that. Mind you, it is the power which depends on time. Right? Not the work. Work done is independent of time. Power in fact is our next article. Power is our next article. समझा बेटा? 3, 2, 1. Your time starts now. Page number 1 thoroughly well. Page number 2 thoroughly well. Revise. जिन महान आत्माओं के पास बुक नहीं है, आज मैं कुछ नहीं बोल रहा. I don't want to lose my temper. Okay? Next time ध्यान रहे. किसके पास बुक नहीं है? मैंने मैसेज भेजा था कल पेरेंट्स ग्रुप पे. Do not forget to get the book of work, power and energy. Do you talk to your parents at home or no? कि no communication. Do your parents talk to you? Do they give the message कि hi जयंत सर ने good evening भेजा ऐसे ही? हाँ? Good morning, good evening के मैसेज आते मेरे कभी? जय श्री कृष्ण, जय जिनेंद्र. है ना? क्योंकि मुझे पता होता है इतना बोलने के बाद भी स्टूडेंट भूलेगा. मोबाइल फोन लाया? मोबाइल फोन नहीं, डब्बा फोन भी लाया ना. फोन तो है ना. मतलब व्हाट इज मोर इम्पोर्टेंट इन आवर लाइफ? फोन की बुक, नॉलेज की टाइम पास? नॉलेज ना. चलो स्टार्ट. सर आपने गुस्सा नहीं करके भी कितना सारा गुस्सा कर लिया। आप अपने हेल्थ का ध्यान रखो सर, वी लव यू, वी नीड यू टिल अवर एग्जाम्स आर ओवर, बाद में आप भले मर जाओ। टेक अ परफेक्ट पिक्चर ना प्लीज। परफेक्ट रेक्टेंगल। Page number 1 done. Yes. Only page number 1 done. Any difficulty? Anybody? Any explanation required again? Carry on. Page 2. Page number 2, everything before the note. Going on is done. उसमें बेटा ध्यान से देखो, ग्राफ में ऐसा कोई मार्किंग नहीं किया जैसा मैंने किया, तो आप लोगों मार्किंग भी कर सकते हो कि सपोज यू आर गोइंग फ्रॉम A to B, then that is the total amount of work done, because A is your initial point, B is your final point. But in between, if you want to find out some small amount of work, then select the points of your choice, preferably very close to each other, because the displacement taken by you should be infinitesimally small, right? That is dx. So if you want, you can do this labeling. I am waiting for you. So now please let me know. Are you done with page 2? Going on? Carry on. You have to finish the notes also. You have to finish up to bottom of page number 2. Are you done now?
Yes, sir.
Okay. Now before I take you on to the next article, that is power, the second term of the title, power. Check please, besides that graph, that was the extra question taken up by me, just like that. But you have similar questions in assignment 1. Last 3 questions. I am giving you 3 minutes. Solve these 3 questions. And let me know whether you are getting the answers or not. You can solve these questions on working space, right side ka right side. Last 3 questions. Working space is on right side. Uska right side, margin ka right side. Your time starts. 3 minutes for you. Should be more than enough. एक छोटा सा क्वेश्चन 41 के बारे में कुछ बोलता हूँ एक्स्ट्रा. क्वेश्चन नंबर 41 में ट्रेपेजियम दिख रहा है. आप पहले वर्क डन ढूंढोगे, लेकिन वो क्वेश्चन में उन्होंने बोला है कि मास ऑफ दिस बॉडी इज 0.1 किलोग्राम. देन व्हाट इज द वेलोसिटी? अप्लाई कॉमन सेंस. वर्क डन कैन बी रिटन एज हाफ mv स्क्वायर माइनस हाफ mv स्क्वायर. उन्होंने मुझे फाइनल वेलोसिटी पूछा है, सो इट इज सिंपली हाफ mv स्क्वायर. वर्क डन आई एम फाइंडिंग आउट यूजिंग एरिया ऑफ ट्रेपेजियम का फॉर्मूला. मास मुझे पता है, वेलोसिटी मुझे मिलेगा. सो 41 में थोड़ा अलग स्टाइल में. योर टाइम स्टार्ट्स नाउ. 3 minutes फॉर यू फॉर 3 questions. 39, 40, 41. जो स्टूडेंट्स का ये 3 क्वेश्चन भी हो गया हो, आगे बढ़ना है, then I can give you some more questions. Actually, that is the homework for you for the next class. So you can do it now. Those who are done with this can also try. Assignment 2. This is the homework for the next class. Homework for next class, next lecture. Assignment 2. Questions 62 to 66. Practice paper 1. Questions 28, 34 and 40. Practice paper 2. Questions 3 and 29. These 10 MCQs are there for homework for the next class. They are all about graphs only. So by chance, if you are done with those 3, you can try this also. Today we are discussing these 3 only, but in case you want to proceed. क्वेश्चन नंबर 39 का आंसर आया बेटा ए। 40 थोड़ा ट्रिकी था, हाँ 40 थोड़ा ट्रिकी था। उसमें आप जब एरिया ऑफ ट्रेपेजियम ढूंढोगे आपका आंसर 300 आएगा। नाउ यू आर लकी कि ऑप्शन में 300 नहीं दिया ना, लास्ट ऑप्शन 300 कर दो। अभी ऐसा क्यों? बिकॉज उन्होंने बोला है कि टू फाइंड आउट द वर्क डन इन गोइंग फ्रॉम 0 to 35। जब आप पूरा एरिया लेते हो ना ट्रेपेजियम का, दैट मींस यू आर गोइंग फ्रॉम 0 to 40। तो व्हाट यू शुड डू, फाइंड आउट द एरिया ऑफ ट्रेपेजियम minus area of that triangle from 35 to 40. So that area of triangle is coming as 12.5. So 300 minus 12.5 is 287.5. You were just lucky because 300 नहीं दिया था, नहीं तो उसमें मिस्टेक करते। फिर अपना माइंडसेट क्या होता है, एरिया अंडर द कर्व, बट उन्होंने 35 तक जाने को ही बोला। सो 40 का भी आंसर आया सबको, 40 का आंसर आया। 41 में वर्क का आंसर क्या है? 41 में 80, वेरी गुड। वर्क का आंसर 80 आया। नाउ यू नो दैट 80 is half mv square. So can I say 80 is half of 0.1 into v square? 80 2s are 160 divided by 0.1 is 1600. So v square is 1600. V should be 40 meters per second. समझा कि वापस बोलूं? 41 में सिर्फ मुझे इतना बताओ कि एरिया ऑफ दैट एरिया अंडर द कर्व कितना आया? 80, बराबर ना? Now that 80 has to be compared with half mv square because this time you don't have to stop at work done. You have to find out velocity of the particle. समझा? Shall I continue? So these are 3 questions. अब जहां पे 41 एंड हो रहा है, जहां पे क्वेश्चन नंबर 41 एंड हो रहा है, वहां पे लिखो on the similar lines. क्वेश्चन नंबर 41 के एंड में लिखो on the similar lines solve assignment 2 question 62 to 66 on the similar lines solve assignment 2 question 62 to 66 practice paper 1 28 34 40 28 34 40 practice paper 2 3 and 29 3 and 29 have you understood up to this? चलो बुक बंद करो, बुक बंद करो। Now power, your school level knowledge. What is the meaning of power? Is it work upon time? या तो rate of doing work. So W upon T या तो dW upon dt. What is the mathematical language of this? Is it derivative of work done with respect to time? So what will be the unit of power? Unit of power will be joule per second, which is also known as watt. Right? What about the dimension? Joule के लिए किलोग्राम मीटर स्क्वायर पर सेकंड स्क्वायर था, तो this will be किलोग्राम मीटर स्क्वायर पर सेकंड क्यूब, and therefore it will be m1 L2 T minus 3. Then I am super sure you must have heard about this. What is the meaning of kilowatt? What is the meaning of megawatt? We use this in power stations. What is the meaning of gigawatt? Right? This is 1000 watt, million watt, billion watt, and so on. This also you must have heard about. 1 horsepower is approximately 746 watts. Now this is called instantaneous power. This is called instantaneous power. That means power calculated by you at a particular instant of time. For example, it is 210 right now. It is 210. So what is the power consumed by all these devices? Everything right now at this instant of time. Now obviously government can not send you the bill, right? Keeping an account of each and every moment. कि नयन वर्मा के क्लास में सुबह 8:32 और 15 सेकंड को कितने लाइट्स ऑन थे, कितने फैंस ऑन थे, कितने एसी ऑन थे। बाद में बच्चों को ठंडी लगी तो एक एसी बंद किया, तो 8:41 को कितने एसी चालू थे। राइट। बाद में ब्रेक टाइम आया, 2-3 में एसी टेम्परेरी बनती है। बाद में फ्राइडे को लेक्चर्स ही नहीं था, संडे को लेक्चर्स ही नहीं था, एक दिन बायो का लेक्चर नहीं था, तो 2 ही लेक्चर्स थे। तो गवर्नमेंट कैन नॉट कीप अ ट्रैक ऑन ऑल दिस, एंड इवन आई वुड नॉट लाइक दैट। Yeah, because government will send me the book as a bill. It will not be a bill. It will not be a single page, and we don't read that single page also. We read only 3 things. एक तो ये मेरा ही बिल है, दूसरा the amount, and तीसरा the due date. Right? Because you don't want to miss that due date. Because otherwise penalty आता है, या तो फिर वो लोग इलेक्ट्रिक लाइन काट के चले जाते हैं कि to hell with you, pay the bill, otherwise face the consequences. बराबर? So government will charge me the bill on the basis of average power consumed. Now how to calculate average power? If power is work upon time, then can I say work is power into time? Therefore, rate of doing work is dW by dt, is power into dt upon dt. So in a way it is multiplied divided by dt. Right? This is power average, which is dW upon dt, which is integration p dt upon integration dt. That means it is integration p dt upon integration dt is dt, t only t. That is periodic time. So this is instantaneous power in going from 0 to t. Because you start from time 0 and you go up to periodic time. Right? Now in a little funny language, we call this as pin becomes pow when you integrate. Instantaneous power becomes average power when you integrate. And your billing is counted on this. And this concept which I have written is very, very important for the chapter EMI, electromagnetic induction, and AC circuits. आपके आजू बाजू में जितने भी circuits हैं, they are all working on AC. Our household appliances are 230 volt AC supply. Is that clear? So mind you, what you have to do is, power is work upon time. So work is power into time. So work upon time is power into time upon time. Multiply and divide by time in simple language, and then integrate. That is the meaning of instantaneous power, average power. Now average power and instantaneous power will be the same if power is supplied at constant rate. This power is supplied at constant rate. ऐसा किधर किया था, याद करो, बताओ, याद करो बेटा। UCM में हम लोग एक्चुअली स्पीकिंग ओमेगा डी थीटा बाई डी टी लिखते हैं, खाली UCM में हम लोग इसको थीटा बाई टी लिख सकते हैं। Yes or no? Because equal angles are covered in equal time. So average power becomes instantaneous power if power is supplied at a constant rate. Now the graphical meaning, super duper simple, super duper simple. ये बाजू का ग्राफ मैंने बचा के रखा है। वो ग्राफ कौन सा था? फोर्स वर्सेस डिस्प्लेसमेंट। उसके बदले if I go for power versus time, if I go for power versus time, and if this is the graph, and if this is the graph, I am going from A to B. I will draw perpendicular on x-axis. I will draw perpendicular on x-axis. This is time 1. This is time 2. So what is area under the curve? What is area under the curve? Is it product of x coordinate and y coordinate? What is area under the curve? Can I say area under the curve is work done? Yes. Area under the curve is work done. In the previous article, dW was f dx. In this article, dW is p dt. सोचो, right? अगर आपको small amount of work done ढूंढना है तो, अगर आपको small amount of work done ढूंढना है तो this is p, this is q, this is perpendicular, this is perpendicular, and the shaded area is, can I say, small amount of work done. So dW is equal to p into dt. Are they looking the same? Yes. This was the concept of work is force into displacement. This is the concept of work is power into time. Just one additional note, because we have done this. Pressure versus volume इट इज बॉयज लॉ। इसका मतलब बेटा ये हुआ V1, ये हुआ V2, ये हुआ एरिया अंडर द कर्व। ओ लवली, dW is equal to PdV, Clausius law, dq equal to du plus dw, where dw is the external one, PdV। ये संडे को फुल पोर्शन है, याद है ना? वेरी गुड, लॉजिक समझा? सुपर श्योर। सो मीनिंग ऑफ पावर, यूनिट्स एंड डायमेंशंस, एवरेज पावर, इंस्टेंटेनियस एंड एवरेज पावर, ग्राफिकल मीनिंग, रेफरेंस नंबर 3। तो अब तक वर्क डन का 3 फॉर्मूला है। dw is equal to f dx, dw is equal to p dt, where p is power, and dw is equal to p dv, where p is pressure, right? Got it? P pressure, P power, P momentum, mass into velocity. Don't get influenced by the symbol. Be careful when you read the question. Understood? 3, 2, 1. Your time starts. Page number 3. Everything except efficiency. Read that page. Everything except efficiency. Somewhere you will come across in dark lines, instantaneous is average power when work is done at a uniform rate. Please highlight that. Chewing-gum खा रहा है, chewing-gum खा रहा है, बेटा निकाल, निकाल और अपने पैंट के जेब में डाल। मैं आऊंगा तो बाल पे चिपकाऊंगा, पैंट के जेब में डाल। नो, पेज में नहीं, निकाल मुंह से। अभी का अभी थिएटर में बैठा है, हाँ, हर एक प्लेस का अपना एक डिग्निटी होता है। कोई भी टेम्पल के बाहर ऐसा लिखा नहीं होता है जूते बाहर निकाल के आओ। हम लोगों को समझ के जूते बाहर निकाल के जाना होता है। चालू क्लास में च्युइंगम नहीं खाना होता। नेक्स्ट टाइम बाल में चिपकाऊंगा, समझा? बिहेव योरसेल्फ। Done? Keep going on. Next article, very simple. Efficiency, eta. We use this in practical life. That person is very efficient, right? Efficiency in the language of physics is defined as output work upon input work. O oblique P means output, I oblique P means input. Or as it is output power upon input power. See, it is something similar to your score out of the total. If you are giving physics exam, board paper, out of 100 you get 73 marks. That means you are 73% efficient. Out of 100 you are getting 89 marks. You are 89% efficient. You are getting 100 on 100. You are 100% efficient. Right? You are getting 0 on 100. You are 0% efficient. Means you have attitude. Right? जाके खाली नाम लिख के आओ, नीचे एक सेंटेंस लिख के आए, पास करके बताओ. So that is efficiency. So efficiency is defined as output work upon input work. So do you agree with me? Efficiency lies between 0 and 1. Because 0 and 100 is 0. 100 and 100 is 1. So it lies between 0 and 1. Do you agree with me? It has no units and no dimensions.
Yes.
Because it is the ratio of the same thing. Remember, somewhere in the past we said that no machine is ideal.
Yes.
Right? Ideally nothing is ideal. Right? Ideal machine does not exist. Matlab you cannot design a machine whose efficiency is 100%. इसका मतलब ये हुआ कि the student getting 720 on 720 also is not 100% efficient. It was his or her day. हो सकता है उसने 4 चैप्टर ऑप्शन में छोड़े थे, 2 फिजिक्स में, 1 केमिस्ट्री में, 1 बायो, एंड दैट पर्सन वाज प्रेइंग कि ये 4 चैप्टर मैंने छोड़े यार, इसमें से कुछ नहीं आना चाहिए, और सच्ची कुछ नहीं आया. 2 क्वेश्चन में डाउट था तो उसने रिस्क लिया कि यार 0 आएगा, -1 आएगा, लेकिन आ गया तो +4 भी आएगा. 2 में फेंका मारा और दोनों राइट हो गया. राइट? इसका मतलब even if you get 720 on 720, that does not mean you have got complete knowledge of physics, chemistry and bio. Einstein had used 13% of his brain during his life. 1-3. That means 87% of grey matter was still not used. We were lucky, otherwise portion would have been. His life did not support it. Yes or no? So imagine Einstein using 13% of his brain during his entire life when his brain was studied. Right? How much brain we must be using? Right? छोड़ो भूल जाओ. Otherwise ये वाली feeling आएगी. Logic समझा? This article again is going to be used in a topic called transformer. आप लोगों ने इसके बारे में सुना भी है वैसे. Step up transformer, step down transformer. Step up means low to high. If you think about the local trains, they are working on 25,000 volt, much higher than 230. And if you think about telephone charger, your mobile phone charger, it is working on 3.7 volt, your mobile phone battery. But you are putting the charging with this only. So that 230 has to be brought down to 3.7. That is called step down transformer. So when you touch the charger, it will be hot. That means it is losing a lot of energy in the form of heat. Yes, sir? So very, very simple article, efficiency. Revise. Page number 3, bottom. लिख के रखो. This article will be useful in the chapter EMI, sub-article transformer. Chapter EMI, sub-article transformer. Before doing page number 4 with you, a little jump. We are moving on to page number 6. Remember I told you, work done is change in kinetic energy. So now we are proving it. Super simple proof. Very, very simple proof. Books band karo, total focus here. Work is force into displacement is better. A small amount of work is force into small amount of work. So small amount of work is force into small amount of displacement. Do you agree with me? Force means mass into acceleration. Force means mass into acceleration into dx. So do you agree with me? dw is equal to mass. Acceleration means dv by dt. Acceleration is rate of change of velocity into dx. Now this method is called method of separation of variables. This method is called method of separation of variables. This was dv by dt, dx alone. I am taking dx by dt together, dv alone. So what is dx by dt? V. So can I say dW is equal to m into v into dv? Right? This is small amount of work done. This is small amount of work done. So how do we find out total amount of work done? Is it integration? It is integration dW. That means it is integration mv dv. Right? Who is the differential element? dv. dv का मतलब change in velocity. That means you are going to change the velocity from initial vi to final vf. या तो फिर initial u to final v. M being constant will come out of the derivative integration. So W is mass out. What is integral v dv? V square upon 2. याद है ना? Integration x raised to n dx is x raised to n plus 1 upon n plus 1, where n should not be minus 1. Likewise, integration v dv is v raised to n plus 1 upon n plus 1. यहाँ पे वो n का वैल्यू 1 है. Yes or no? So it is v square upon 2. In going from initial velocity u to final velocity v. How to solve this integral? जिधर जिधर v, उधर उधर v. Minus जिधर जिधर v, उधर उधर u. Upper limit minus lower limit. So my final step is w is m by 2 v square minus u square. Can I say, oh lovely? This is final kinetic energy minus. So can we say this is final kinetic energy minus initial kinetic energy? That means change in kinetic energy. Statement proved. Statement proved. Work done is change in kinetic energy. Now something very, very important. Kinetic energy can never be negative. But change in kinetic energy may be zero, may be positive, may be negative. Give a thought. I am driving the car. My speed is 20 kilometers per hour. Now it is 30. Now it is 50. Now it is 80. Can I say I am going with increasing velocities? Kinetic energy is positive. All of a sudden I see red signal. I start applying brakes from 80 to 50, 50 to 10, 10 to 0. Can I say difference of kinetic energy will be negative? So work done is negative. Now I am on a highway, express highway. No signals, no speed breakers, no one ahead of me. I am putting my car on cruise mode, cruise control mode. 80 kilometers per hour because I want to have a cup of coffee and I want to read newspaper. So my car, yeah, autopilot mode में ऐसे ही होता है. By chance तुम लोग पायलट की कैबिन में चले गए तो पता चला उधर पायलट न्यूज़पेपर पढ़ रहा है, कॉफी पी रहा है. तो बोलोगे यार प्लेन कौन चला रहा है? It is on autopilot mode because once you reach a particular height, birds cannot reach there. You cannot have any obstacles. Like the highest mountain is Mount Everest, 29048, and the plane is flying at a height of about 35, 36, 40,000 feet above the sea level. So you know there is no mountain cliff also where your plane is going to collide. So when you are on long flights like Bombay to New York and all that, out of 17 to 18 hours, 3 to 4 hours, so nobody is flying the flight. Right? It is on autopilot mode. बीच-बीच में शायद पायलट को नैप भी आ जाता होगा. Of course, co-pilot is there. But then also, autopilot mode helps you and it just gives you warning. Tesla car is what? You don't need to drive. It itself is driving. Future में they will not need you at all. Right? कार का front seat पे कोई नहीं होगा. आप पीछे बॉस की तरह आराम से बैठो. Automatic powerful sensors are there. If somebody is crossing the road, something comes in between. The sensors will detect this very powerfully. The car will automatically stop, automatically park, automatically start. घर पे जाके आप 50th floor पे रहते हो, पता है यार याद नहीं आ रहा मैंने गाड़ी लॉक किया था कि नहीं. तो from your Wi-Fi password and strong GPS signals, you can lock the car from your flat also. Right? That is going to be the future. That means human beings are going to become super lazy. It will be the time of artificial intelligence. Sir, anyways we are lazy. Page number 6. Title work energy theorem, lower half. Page 6, lower half. Page 6, upper half temporarily छोड़ दो. Page 6, lower half, work energy theorem. Page 7, top 3 lines. Page 7, top 3 lines. Your time starts. Done? Next, books burn. Theoretical article again. But luckily, you've done this part little bit in electrostatics. You've done conservative and non-conservative force. So this is just kind of a revision. You also know what is the meaning of central force. What is the meaning of central force? A central force is the one which acts along the line joining the centers of two bodies. Right? Conservative force and non-conservative force. In conservative force, you know that the work done during the round trip is zero. The work done is completely recoverable. The work done is independent of path. Right? For conservative force, the work done is independent of path. If I want to go from this point to this point, maybe the direct route is not there, so I am going this way. Maybe this route also is not there, so I am going in a zigzag way, whatever motorable road is there. But ultimately work done is force into displacement. So it is independent of path. Whereas here it depends on path. Here it depends on path. Over here, kinetic energy and potential energy may be variable. Right? Example, oscillation. Kinetic energy and potential energy are very variable. But total energy will always be constant. Yes or no? Whereas over here, total energy is not constant. For example, when you throw a ball on the wall, some sound is produced. That means the kinetic energy of the ball is not completely given to the ball. Some part is lost in the form of sound. Right? For example, when you rub your palm, depending on with what intensity you are rubbing the palm, accordingly heat energy will be lost. If I am simply doing this, nothing. Right? If I do this, and if I do this for a longer time, I will literally feel hot. That means the electrons beneath my skin are excited. They will go to the higher orbits. As per the rule, they cannot remain in the higher orbits. So the extra energy has to be liberated in the form of action, energy bundles, quanta, and accordingly I will feel that energy. Right? So over here, the energy is recoverable. Whereas over here, the energy is not recoverable. Whatever is lost is lost. It is going to the surrounding, I am not getting it back. Over here, work done during the round trip is zero. Over here, the work done during the round trip is zero. Over here, the work done during the round trip is not zero. So if I had 10 joule over here, maybe it was in the first quadrant. Maybe I have 10 joule in the fourth quadrant. Ultimately, the sum total will be zero. So that is work done during the round trip is zero. Now, what examples in this surrounding are coming across these categories? You have heard about F is equal to G, M1, M2 upon R square. Gravitational force. You have heard about F is equal to 1 upon 4 pi epsilon naught. Q1 Q2 upon R square. You have heard about F is equal to mu naught upon 4 pi m1 upon m2 m1 m2 upon R square. Looking at the response, you have not heard about. No problem, no problem. This is gravitational force. It talks about force between two masses. It says that it is directly proportional to the product of the masses and inversely proportional to the square of the distance. This is electrostatic force. It is directly proportional to the product of the charges and inversely proportional to the square of the distance. This is force due to magnetic field. It is directly proportional to the force between the magnetic charges and inversely proportional to the square of the distance. This is constant of proportionality known as universal gravitational constant. Known as universal gravitational constant. This is called permittivity. And this is going to be called permeability. ये आप लोगों ने सिर्फ सुना है, अभी तक फेस नहीं किया है. चैप्टर मेजरमेंट्स. म्यू नॉट इज 4 पाई into 10⁻⁷ वेबर पर मीटर. तो अभी तक ये सुना है सिर्फ, अभी तक ये प्रूफ नहीं किया है. So don't worry about that. The next force which you have heard about is spring force, which is kx in magnitude. So all these come under the category of conservative forces. Now non-conservative force means there is one or the other way there is a loss in energy. Frictional force is non-conservative. Viscous drag is non-conservative. Current carrying wire having magnetic field around. This is current carrying wire. This is having magnetic field around. That will produce heat. This is non-conservative. What do I mean by this? Frictional force. I am dropping this body into a bucket containing water. So for some distance it is traveling through air and then it enters water. Air also offers resistance to this movement. Water also offers resistance to this movement. Who offers more resistance? Water. Obviously, because density of air is 1.29 kilogram per meter cube, whereas density of water is 1000 kilogram per meter cube. So when the resistive force is offered by a fluid, fluid means the substance which can flow. Liquids and gases come under this category. We have done this in expansion of fluids. So that is called frictional force. अब यहाँ पे ना कुछ equations आएंगी जो आप लोगों ने अभी तक किए नहीं. When I give you time to read the notes, you will come across an equation called Stokes' law. Now this Stokes' law says that if this is a rain droplet and if it is traveling through air, then this raindrop is going to experience a viscous drag which is given by 6 pi eta RV, where eta is called coefficient of friction, R is the radius of the drop, and V is the velocity with which the drop comes down. I am sure you have heard about Millikan's oil drop experiment. Yes. Fantastic discovery in the field of physics and chemistry. Thomson was the first one to calculate Q. Then Millikan came, he calculated Q by M. And then Q by M and Q, both are known. So Q upon Q by M is M is known. And this is the mass of the electron was calculated. Fantastic achievement in the field of theoretical physics. You cannot have a weighing machine where you can put electron on one side and weights on the other side and then check how heavy baby you are. You cannot find out the mass of the earth also like this. Mass of the earth is calculated using astronomical telescopes. Right? From the outer space, the Hubble telescope is sending you the pictures that will calculate the diameter of the earth. You know diameter. That means you know radius. That means you know 4 by 3 pi r cube. That means you have calculated volume. Density of the earth is 5500 kilogram per meter cube. So rho into V means mass of the earth, and that is 6 into 10 is to 24 kilogram. You cannot go to the sun to measure the mass of the sun. Mass of the sun is 2 into 10 is to 30 kilogram. And it's a blazing mass of gas, hot gas, very hot gas, hydrogen and helium. Right? When Big Bang theory took place and when the universe was formed and our solar system was formed, that time it was 100% hydrogen. Then 4 hydrogen nuclei constantly combined together to give you 1 helium nucleus, 2 positrons, and tremendous amount of energy. So as per the present calculations, still in the atmosphere of the sun, 7% of helium is there. 93% of hydrogen is still there. So it is going to give you energy for next 500 billion years. तुम लोगों में कितनी ताकत है उतनी एनर्जी लूट लो तुम लोग, फिर भी सन का एनर्जी खाली नहीं होने वाला है. The problem is not solar energy. The problem is how to store it. Yes or no? Are you getting this? That is why all over the world now they are going after solar energy and green energy. Getting my point? Okay. So this is called Stokes' law. Then you will come across a law which is called force vector is IL bar cross B bar. This is called Lorentz force equation. Mind you, this is non-conservative force. Lorentz force equation. Now what does this mean? If this is a wire whose length is L, and it is carrying current I, current carrying wire will have magnetic field around, and this magnetic field is B. भले आप लोगों ने ये इक्वेशन के बारे में नहीं सुना है, लेकिन इसके डायरेक्शन के रूल के बारे में सुना है, फ्लेमिंग्स राइट हैंड रूल. बराबर? If this is my palm, and if I am holding this current carrying wire, my fingers are coming towards you. That means this is magnetic field out. And now when I curve my fingers, that means on this side, the fingers are going in. So from here, my fingers are pointing in. So that is called cross. And from here, my fingers are coming out. That is called dot. Right? Cross means in. Dot means out. याद रखने का technique. Get out. Dot out. Dot means out. Cross means in. So maybe you've not heard about dot out. Means magnetic field is pointing out. Understood? No? Get out. Dot out. Cross in. So maybe you have not heard about this equation. Which equation? This equation. But you have heard about the direction. अगर बेटा ये एरो में उल्टा कर दो, ये एरो अभी ऐसा है ना, थंब इंडिकेट्स द डायरेक्शन ऑफ करंट. अब अगर मैं उल्टा कर दूं, तो दिस साइड इट इज आउट and this side it is in. Got it? So this is Fleming's right hand rule. That you have heard. Means you have heard only about the direction. I am talking about the magnitude also. काफी सालों पहले की बात है. चैप्टर वेक्टर्स. वहां पे मैंने लिखा है F is IL bar cross B bar और बाजू में लिखा है wait for EMI. जाके देख लेना examples of cross product. इधर वापस लिख के आएगा wait for EMI क्योंकि नहीं हुआ है. F का मतलब फोर्स, I का मतलब करंट, L का मतलब द डिस्प्लेसमेंट वेक्टर, मतलब लेंथ ऑफ द वायर इन अ पर्टिकुलर डायरेक्शन, और B का मतलब मैग्नेटिक फील्ड. So these are all examples of non-conservative force. Now where you have to be alert. Magnetic force is coming under both categories. If you think about this magnetic force, it is conservative. And if you think about this magnetic force, it is non-conservative. So if my question is, magnetic force is, options, conservative, non-conservative, both, none. Answer is both. But if I am specific about that question, magnetic force between two magnetic monopoles is conservative. Magnetic force due to the current carrying wire. You have to be very alert. This is NCRT pickup line. This is NCRT pickup line. Now two very important things. In oscillation, last class में हम लोगों ने बहुत ही complicated equation किया था और उसके questions किए थे. याद करो बेटा. F was negative derivative of x, or u with respect to x. Right? That means force is negative derivative of potential energy with respect to x. इसका मतलब ये हुआ कि potential energy can be explained only on the basis of conservative force. Only on the basis of conservative force. The concept of potential energy cannot be explained if we are talking about non-conservative force. Reason, some energy is lost. I don't know how much energy is lost. I don't have a control on that. Are you getting this? So the concept of potential energy is expressed only on the basis of conservative forces. One of the most favorite MCQs theory wise from this topic. F is negative derivative of u. ये पार्ट समझा? ये बेटा फिजिक्स में भी उतना ही इंपॉर्टेंट है, केमिस्ट्री में भी इतना इंपॉर्टेंट. In future, in chemistry, we are going to study one graph. Right? This graph is like this. Over here, the atoms are closest to each other. So it is said to be the most stable. If the distances are this way or this way, then it is unstable equilibrium. We are going to do this in physics also, right? And we are going to do this graph also. यहाँ तक सब कुछ समझा? Super sure. अब ये पेज रीड करने का एक स्टाइल है. मैं जो स्टाइल में बोलता हूँ वही स्टाइल में पढ़ो. Are you on page number 4? First of all, mark this page very important. लिखो, this page is very important. Theoretical MCQs wise. Page number 4 is very important. Theoretical MCQs wise. अब एकदम ऊपर देखोगे ना तो पैराग्राफ फॉर्म में दिया हुआ है कि वो भी मीन बाय कंजर्वेटिव एंड नॉन कंजर्वेटिव फोर्सेस. उसके बाद में ये जो मैंने एग्जांपल्स लिखे हैं 4 इधर और 3 इधर, वो दिए हुए हैं. उसके बाद में टेबुलर फॉर्म दिया जो मैंने ड्रॉ किया. राइट, डिस्टिंग्विश बिटवीन, काइंड ऑफ डिस्टिंग्विश. आप लोग सीधा डिस्टिंग्विश पढ़ो, फर्स्ट पैराग्राफ पढ़ने की जरूरत नहीं. तो जहां पे डिस्टिंग्विश लिखा है उधर लिखो स्टेप 1, पहले वो पढ़ने का. उसके बाद में ऊपर आओ, एग्जाम्पल्स, दैट शुड बी स्टेप 2. दोनों का, कंजर्वेटिव का भी और नॉन कंजर्वेटिव का भी. समवेयर इन बिटवीन यू विल कम अक्रॉस अ डार्क लाइन कि मैग्नेटिक फोर्स इज कमिंग अंडर बोथ दी कैटेगरीज. हाईलाइट करो इसको. और एकदम एंड में नोट है, चेक करो. वो नोट का एकदम लास्ट लाइन पढ़ो एंड मार्क इट 10 स्टार. पेज नंबर 4 का लास्ट लाइन पढ़ो, एकदम लास्ट लाइन, एंड मार्क इट 10 स्टार. बराबर. Now one small thing before I make you read this. Go back to page number 6. वहां पे सेकेंड लास्ट लाइन चेक करो. Is W equal to K final minus K initial, या तो W is equal to डेल्टा ई के. बॉक्स में डालो उसको. अपने पास राइट साइड में इनफ ब्लैंक स्पेस है, वो ब्लैंक स्पेस में एक नोट लिखो, नोट. सिमिलरली W is equal to change in potential energy. Similarly, W is equal to change in potential energy. For example, for a spring, we can write W is equal to half K. W is equal to half K bracket x2 square minus x1 square. Bracket x2 square minus x1 square. What is half k x square, by the way? Potential energy is stored in a spring. So this is difference of potential energy. Got it? Time to revise page number 4. Word to word, line to line. Style to revise. पहले tabular form, distinguish between. उसके बाद में examples. And उसके बाद में note. Right? This is where we will stop today. And homework for you for the next class will be those 10 MCQs graph wise. Okay? Stop the recording. This lecture will not be included.